He has been involved in organic farming since 1983, working on various farms across the United States before selling now the Cumberland Valley. Recently, as of tonight, the internet's ahead of this whole thing. Matt was honored with the prestigious Epstein Lifetime Achievement Award. You guys just witnessed it. By the Sustainable Energy Fund for his significant contributions to sustainable energy practices. He co-founded the 80-acre educational production farm at Dickinson in 2007 and has been instrumental in implementing renewable energy systems, including solar thermal, PV, electric vehicles, and a biogas system, which is tonight's topic. So tonight, Matt will be discussing and demonstrating how biodigesters can reduce waste, produce energy, and help regenerate soil. Looking forward to that. And then following Matt will be Larry Amy. Here's Larry. He's chairman of the board of directors of the Sustainable Energy Fund, which, by the way, thank you for hosting us here today and providing the refreshments. Thank you. So the Sustainable Energy Fund is also a 501c3 nonprofit. They assist energy users in overcoming educational, financial, and regulatory barriers to a sustainable energy future. 3 primary tasks they perform. Larry, tell me if this is not correct. Finance clean energy projects. They educate leaders and raise public awareness of sustainable energy. And then they invest in clean energy programs and companies. This places SEF at the forefront of the Inflation Reduction Act, which is one of the topics that I'm going to talk about this evening. With that, turn it over to you.
Super. All right. Well, I'm so glad to be here with y'all, and thanks for having me. Thanks to Maria, and great to be back in touch after so many years apart and to see some old friends. So I am here to share with you my passion for biogas digesters and to hopefully answer a lot of your questions about what it takes to operate a biogas digester. My first biodigester was made in the basement of my house, a little 2-gallon jug of sheep manure and water. Quickly that got kicked out outside when a 2-year-old kid knocked it over and spilled sheep manure all over the floor of the basement. But we've been making digesters at Dickinson College since about 2008. We've made dozens of small ones, and then a progression of larger digesters. The last owner-built digester we made was in 2015. We built a 1,000-gallon digester that we use for making cooking fuel for the farm. And so I'll take you through that process of making our own digester.
This morning.
All right. Using that for cooking fuel. And then the next step for us was when we had more cooking fuel than we needed, to progress to a biogas to power system. So that's what we're operating now. Is we have a 48 kilowatt grid tie generator installed, and we're making power from the manure from 100 to 150 dairy cows and 2 to 3 tons per day of food waste. I have some pictures to show. I have a demonstration outside, but I hope you ask a lot of questions and kind of we can take things as they go that way as well. So I can talk to you for the next 75 minutes, but I would love your questions to make it more engaging. Are folks ready to go outside and see biogas in action for just a second?
Sure.
Right. So here we have some very simple stuff that makes the biogas digester, and then I've got it's loaded with the right microbes that we need to convert biomass, including food waste.
Food waste also.
Yes.
So you don't have to change the mix.
Well, it's not, if you can, it's nice to get some seed from another digester that's already running on food waste. But you can start with cow manure by itself. So the big digester we have at the farm now, we started that with just cow manure from the dairy cattle that we're working with. We made some nice gas, and I got a tanker load of seed from my friend's farm where they have been running on food waste for years, and that really jump-started stuff as a durable culture, so to speak. But microbes are pretty adaptable, and as long as you manage them in a way where you're not overfeeding them, you respect them and their parameters, then they will adapt to what you feed them. If we take our time with that, so to speak. And I can talk more about that inside in the warm. Go ahead.
Isn't it kind of dangerous if you don't purge it and you start getting gas? Explosive mixture in there?
Great question. So methane in combination with oxygen is explosive. Methane, like this by itself is not explosive. It's when it mixes with air that becomes explosive.
But you've only got that portion filled.
Right. So, but there's no spark in there. Right? So I would just say that I've done a lot of these for years, and even I'm a little bit casual about fire around them, and we have not yet blown anything up.
See a way to put it.
Yeah. So I think you can relax a little bit, but you want to be use common sense, I guess. But yeah, this by itself, a little biogas in there. There's not a lot of spark to ignite it, and if there's not enough gas in here to really do much damage. Okay, so in a confined space, lots of gas, lots of air, then you can start to worry. I hope that answers your question.
Yeah, I think the auto ignition for methane is much higher. So auto ignition temperature for methane is much higher.
Oh, but a spark would do it, wouldn't it?
Yeah, with spark.
Electrostatic spark.
Yeah.
Very little flame point though, too, right?
Yeah.
So it's
Still,
just kind of ignites and it's
Right.
not very condensed energy like gasoline.
For example, we can do this, right? Like there's biogas here, and I respect Phil. I'm not going to burn him, but so like there's gas there. It's on fire. And I'm not particularly afraid that I'm going to blow us all up. Okay. I'm not trying to be casual about it, but that.
Kelly's way out on the sidewalk.
Okay, so this is kind of a demonstration, all right? We use these to teach kids. If you have 4 of these in a little battery, if you change what you feed them, you can make some experimental deductions about how much gas you get from different substrates. That's an example. Okay, so I have 4 of these in a classroom at a middle school right now. And they're feeding, one eats a banana peel. They all start with manure and they feed different things and get different amounts of biogas. You're not going to really cook for your house with a
So
little
do you
digester
just
like
place
that.
water to determine how much gas you get?
Yep, we do. Or actually, I like a floating cylinder. So we make a giant graduated cylinder out of a 4-inch sewer and drain pipe. Cap it, invert it, mark it with graduations, and then how much that floats. Water displacement, you have the back pressure of water working against you, whereas a floating cylinder, that's a nice way to do gas collection. So in my master's research, we did a battery of floating cylinders like that. I'll show you a picture inside.
Okay.
Great question. So demonstration batch digester, right? If you put an inlet and an outlet port on there, if we take a tube and stick it on the side and take another tube and stick it on that side, and we can load it on one end and evacuate it on the other. Then we have a flow-through digester or a continuous feed digester. We can feed it a little bit every day, waste a little bit every day, and that one will perform research for you, which is really nice. So all we need to do to mix it, stir it up, agitate the slurry, and by evacuating a little bit every day and feeding a little bit of fresh material every day, the culture stays nice and happy, and you can get a really stable digestion that way. All right.
Ratio of solids to water?
Great question. We want to be at about 10% solids or less. So we operate between 5 and 10% solids for what's called there's a lot of farm digesters around 5 to 10% solids. So at that ratio, it's like kind of looks like a milkshake, okay, or a little thinner than a milkshake, like a pea soup. It will flow through pipes. So we want to be able to flow through pipes and pumps without hanging up. If we have too much fiber, too much solids in our material, as the biogas bubbles start to form, and if I had a glass jar of slurry here, you'd actually see little bubbles of biogas forming in there. As they form, they will catch in the fibers of your slurry, and you get foaming on the top of your slurry if you have too much fiber. So that's something to be careful about. Is we want to keep things flowable and not get too greedy with how much we feed it, because that foam, if it comes up here and clogs my gas pipe, then I have some troubles.
How much of the fiber, if any, breaks down in the digester?
Great question. So if we measure, say we started for example, here at 7% solids, and we were to digest it for about 30 days, we might come out with like 4 or 5% solids. So that 2% solids that went away is what became your biogas. And you could actually do stoichiometry if you really
So not too much of the fiber. Okay.
Right, yeah. But so, okay, and there are certain fibers that are harder to digest. So food waste is very easy to digest. Okay, if I put pasta and carrots and rice and things like that in there, they digest very readily. Okay, but things like hay, straw, a lot of the parts of cow manure that the cow couldn't digest, they actually go right through the digester and come out as solids. Now that's useful in a farm project because we can use those solids as cow bedding. We can actually remove them from the digest state, the liquid that comes out, and separate them with a machine and use them as cow bedding. Just as an example. Okay, but so I made a point there already, jumping ahead of myself, but cow manure, it's full of microbes. It's great for digestion, it's very stable, but it's not very energy rich compared to food waste. Okay, what come out of a cow is like the stuff that the cow didn't do a good job of digesting already. All right, so cows eat like a kind of low energy substrate. They eat grass, they eat hay, maybe they eat soybeans, depending on where they are, and they take some energy out of that to do cow stuff, and they poop out the rest. And what they poop out is hard to digest, right? It's the recalcitrant fibers, and so the microbes in here are coming from a cow. They're not going to do a whole lot better job of digesting those materials. They will continue to digest them, but what's much more digestible is food waste, because if it didn't end up in the garbage can at our cafeteria or a restaurant or what have you, we could have ate it, right? So it's a hamburger, it's a pancakes, think of all the things I saw this morning coming out of the food waste bin. Those things are energy rich, and so we tend to get 2 to 3 times more biogas per unit of mass from food waste as we do from cow manure.
So do you generate a lot of water? Because food has a lot of oxygen. So
Great question. Professor? The reaction does result in water, doesn't it?
Yeah, it does result in water too, yeah.
There you go. So there is the methane reaction does result in some water, but we tend to find so right now I'm loading in our digester about 3,000 gallons a day of cow manure, food waste, and water, and what's coming back out of the digester every day is about 3,000 gallons of digestate. Okay, and we're squeezing that to get the bedding out, and the rest of it goes to our fertilizer storage tank.
So it would depend on the feedstock that you're using. Some of them would have water, mostly in form of moisture, but yeah.
well, there's also there's moisture content in the food, and then there's moisture from the reaction because it's a reduction to reduce methane.
Yeah, absolutely. So yeah, we're putting in apples right now, doing a lot of apples, and apples are probably, more than 80% water.
Right.
Even our ground food waste from the cafeteria is about 80% water, 20% solids. Okay, I don't want to get too far in the weeds while we're out here. I wanted to show you guys some fire, and then we'll go back inside. So, batch digester, biogas. Turn off the valve, man. All right, same thing. This is a little Chinese pump. Okay, rural China in general, India, they're both way ahead of the States on small biogas. Okay, there are like 30 million small biogas systems in rural China. All right, we're already burning. Yeah, pressure on there. Okay, this is a Chinese stove. I got this in Yunnan province. 15 minutes walking around asking at hardware stores, do you have a stove for Zalchi? And yes, of course. Whereas here in the States, you go to a hardware store, an Ace or whatever, and ask for a biogas stove. You're going to look at you funny, right?
Methane,
You mentioned meat. Putting meat in as well. Eat meat and fish.
Yeah, meat, fish.
Okay.
Yeah, it all goes in there. So protein is good.
Right.
Carbohydrates, sugars, fats. You got to watch too much fats, oils, and grease, and you can get scum. And that scum layer can become a foaming issue. So fat, like cooking oil, a little bit, bakery waste, that kind of stuff. It's very energy rich, but if you overdo it, you can have some issues. Now, the nice thing about a farm digester, we're doing co-digestion. So we have cow manure and food waste in our project, and that cow manure is this like steady baseline. Every day we're getting 1,000 gallons of this microbe-rich manure, and then we put the food waste on top of that to juice the energy out. If that makes sense. But we got to be careful exactly what we put in there. But I say that, but, we're feeding apples, cafeteria waste, bakery waste, brewery grain, restaurant waste, farmers market waste, produce from our farm, things like that. Every day is a little different, but it's kind of variations on the theme. If that makes sense.
Is methane the only gas coming out? No volatile organic compounds?
Great question. Biogas is primarily carbon dioxide and methane. So we have about 60 to 65% methane, depending on the day. And then our other gas is carbon dioxide, and we have a little bit of hydrogen sulfide. So I'll run, if I have any gas left after we pop the corn, I'll run my tester here. Turn this down.
quick.
This pump has a dial on it. Okay. So VOCs, I do not believe we have VOCs in herbicides. Again, I'll defer to Professor.
No, I didn't get that.
Any VOCs in the biogas, Professor?
Volatile organic matters. Usually most of the gases we account for is hydrogen sulfide, like you said, carbon dioxide and methane. Yeah. Those are the main traceable ones that.
So hydrogen sulfide is important to be careful with. In a confined space, hydrogen sulfide is poisonous. Okay, so we don't want to breathe hydrogen sulfide. We don't really want it in our machine. So for a household stove, we can scrub it out with a device like this. Pass the gas through this little scrubber, and that will help to reduce the hydrogen sulfide content. That's like going to be an iron oxide. At the college farm, bigger digester, we have a big activated charcoal scrubber right now. So we're doing the H2S scrubbing. We're going from about 1,300 parts per million H2S of raw gas to down to like 0 or to 10 parts per million after the rest of that charcoal scrubber. So pretty exciting. Okay, I really hope I get some corn to pop because I also want to test the gas for you guys. We're so close. You're it. It's sizzling, okay. If you were kids, you'd be really disappointed if I don't pop the corn. But maybe as adults, you'll tolerate.
You're out here in the cold wind, that's part of the problem.
Yeah. But we can all see the fire, right?
Oh, yeah.
Okay. It's very hot. Hot fire. So at my house, my wife and I went about 3 years cooking on biogas regularly. Okay, now we moved off the farm. We don't have an easy source of biogas to bring home. And so we're not cooking with biogas right now. At our farm, we also have a commercial kitchen. And for about 5 years, we were using biogas to make pickles, things like that. I have been really focused on the commercial project for the past year and a half, so I've slacked off my pressure on the kitchen to like always cook on biogas. But we burn a lot of biogas for cooking fuel. I have some friends here in Pennsylvania who are big time enthusiasts, like dyed-in-the-wool biogas people, and they cook on biogas every day, as well as they have another stove in their kitchen. Oh, so disappointing. Should have brought 2 inner tubes. We're so close. If I was frying eggs, we'd be done by now. Okay. Oh yeah, there you go. Good. I'll get my gas tester out.
How long does it take to fill the tire?
That tire, so I didn't fill that with this digester. I filled it with the big digester today. This one would take a couple days to fill that. Yeah. So what?
It's every direction.
A little digester like this, running steady, well taken care of, will generate about 7 or 8 liters of biogas a day. And so that, I'm not sure how many liters are in that inner tube. Let's see. I'll show you some pictures of biogas bags. And side. And those bags, they can run.
All right, we believe you now.
Okay.
I'll take over.
All right, excellent, thank you. Those biogas bags, it's a 2 cubic meter biogas bag. We can run about an hour to an hour and a half on the stove. Like that. Oh, we're so close.
Got it?
Okay, this is a very nice device. This is your tax dollars at work. The EPA bought this for us. This device is what we use to check the gas quality for either research projects or our larger commercial project now. So I check about every day the gas quality. We're looking for methane content as well as hydrogen sulfide content. All right. Oh man, what's more important? You guys want to see the gas measurement?
Yeah.
Sure.
Yeah.
All right. I'm gonna stop you there.
That's fine.
All right.
Sure.
Okay. So sorry guys.
So is that electrochemical or?
I have no idea.
No idea.
That's a great question. All right, but I do know. You turn the fan, and so we'll start to see the methane content go up pretty quick. Yeah, that's the balance.
Both
Yes.
sides, so.
Yeah. Yeah. Okay. Hopefully I got enough gas in here.
Methane, the top one?
Yeah.
Yeah.
Methane's the top one. Oh, we're so close.
Surprised the O2's still so high.
Would you hold that? All right.
Yeah.
I'm gonna try to chase
Tilt
some
it a little
gas.
bit more. Tilt it more. There, that's better. Thank you.
You getting anywhere?
Yeah.
All right, 45. We're getting there. So it takes a minute to purge the balance gas, which is the air that was in the tube, and then I don't have a perfect system here, but so we can see we got some methane there, right?
What's going on?
48 going up. Okay, and the hydrogen sulfide, we can see a little hydrogen sulfide there on the bottom, 218 parts per million. That's pretty low, really. So biogas, burnable gas, as you can see, is somewhere around 50 to 60% methane, and it'll burn. Okay, what we want for our engine is around 60% methane to run, running a good tune. Our engine will run down to 50%, but it starts to get less happy at that point. All right.
Well, hydrogen sulfide's been steady at around 18.
Okay.
You want that higher?
That's
Or is
balanced
that-
gas, actually. So we're leaking a little bit of air in here somewhere. I have it kind of an imperfect
Not much. 5% oxygen.
farm rig system. Yep.
Sorry.
Not much air is leaking in. There's only 0.5% oxygen.
Yeah. Okay.
Is there any way to scrub out the CO2?
Yeah. I'll take that back. Okay. Thanks for your help. That was great. Okay. Looks like that's about where we're at. Biogas is so somewhere around 30 to 40% CO2, and if you want to scrub it out, then you're going to be making what's called RNG, renewable natural gas. So there are on much larger projects, they scrub out the carbon dioxide, get up to like 95 or higher percent methane, and then if you have a high enough purity methane, you can inject it into the pipeline as natural gas. There's a couple different technologies to do that. Most of them are quite expensive. So typically, it's like $1 million to scrub the carbon dioxide out of the biogas. So that's going to be a much larger farm, like a 10,000 cow dairy, or there's a big one now going into Western Pennsylvania where they're going to they have like 10 farms that are contributing their manure to scrub out. All their manure is going to one place for a big digester. They scrub out the carbon dioxide and they're injecting that into the pipeline. RNG is much more valuable than biogas because we can sell it to California where they have these renewable fuel standards that are more aggressive than here in Pennsylvania. Or you could possibly sell it to virtually sell it to another company that needs sustainable fuel. Biogas to power, we are making electricity without needing to scrub out the CO2 because we have an engine that runs on clean biogas, but not without with the CO2 intact. And biogas to power, we can then just sell the electrons right into the grid, so to speak. So a farm of our scale probably is not going to do renewable natural gas. We have 100 cows. We're making 25 cubic meters of biogas per hour. Much bigger farms, it becomes cost effective to do that. Great question.
Can I take a quick picture?
Oh yeah, sure.
Thank you.
All right, shall we go inside?
Sure, sure.
Okay, I apologize for the letdown on the popcorn gang. We don't often fail on that one.
We saw the flame.
We heard one pop.
There was real fire. We popped the kernel.
Pop 2 kernels.
Next time I'll bring the
How's
eggs.
the odor?
Oh,
Out of there.
out of here, you can smell a little bit of hydrogen
Little
sulfide.
bit, yeah.
Hydrogen sulfide smells like sulfur.
Mix.
Like,
Yeah.
Rotten
Mix,
eggs.
yeah.
But you don't want to get right up there and sniff it because H2S is poisonous. So we're gonna go around to get back inside.
Okay.
Okay. We talked a little bit outside. I want to show you some pictures of our project because I think pictures are worth a lot. And then continue to take questions. So don't be afraid to fire them off as we go. Thank you, Phil. Great. All right. So we start off with the inner tubes, like you saw there. There's our big digester on the other side. Just a quick word from my sponsor. I work for Dickinson College Farm, and we are a organic farm and an educational program. We grow vegetables. We grow students. We compost a lot of material, and we do a lot of sustainable energy education. Always thanks. We're in Cumberland County, Pennsylvania, south of Harrisburg. Carlisle is the town. All right. So we have been in food waste for a long time. We collect food waste from the cafeteria. It used to be all for compost. And every day we bring in about 1,000 pounds of food waste for composting. We have a pulper in the cafeteria there. So all the kitchen scraps, as well as the post-consumer food, is going through our pulper and then come out to the farm. So far, since 2008, we've collected about 3.5 million pounds of food waste for processing on the farm into compost. We started experimenting with biogas from that about 2015. Here's our windrow turner making compost. When you turn compost, you often don't see steam coming off the compost pile. I'm sure some of you are composters. You know that your compost piles will melt snow in the winter, and they'll give off steam when it's cool outside. So this is showing us that there's energy in the materials that we put in there. It's released as heat in an aerobic system. Okay, compost piles are aerobic if done properly. We have oxygen there. The microbes are converting the food waste and the leaves that we put into our compost. They are digesting them in one way and releasing some of the energy that was in those materials as heat. Okay, if we have a lot of microbes in one place, we get a lot of heat. We can actually raise our compost piles to a nice, happy 150 degrees Fahrenheit, etc. If we don't have air in the system, we get what's called an anaerobic digestion. And if we have the right microbes, we can go all the way to methane. Okay, so the microbes that are in the cow manure or that are in sheep manure, there's some in our human guts as well. There's other ones on the planet. They can be used to digest organic materials into biogas and simpler compounds. Okay, so we start off with complicated things like a stick of spaghetti, some carbohydrates, some proteins, some fats, etc. And we break them down into simpler organic molecules. And in that process, we release biogas, which is again carbon dioxide and methane, and a little bit of hydrogen sulfide. The gas is burnable, as you saw outside. We can use that as an energy source. We burn the biogas, we generate a little bit of CO2, or release some CO2 to the environment. But the CO2 that we're releasing originally came from the air. Think about it. We're feeding a cow some plant material, or if it's a food waste, it's also kind of plant material. Maybe it was a crop that we grew, or it was a piece of meat that came from cows, etc. So our carbon that's in our material that's feeding the biodigester is coming from the atmosphere to begin with. All right. So when we burn biogas and release carbon dioxide back to the atmosphere, we're just cycling atmospheric carbon back to the air. All right. And the driver of that system is the sun. So really, biogas systems are kind of like, a biological solar power system, so to speak. Right. And we can consider them carbon neutral, or in some cases carbon negative, if we are dealing with a source of methane emissions. Okay, if you have a dairy farm that has a big manure pit that's bubbling up methane to the environment to begin with, methane is a pollutant when released to the air. we can capture that and use it as an energy source, and we're actually essentially becoming carbon negative in those cases. All right, one other thing is the liquid coming out of the system after it's been digested is a great fertilizer for crops, because biogas, again, it's carbon dioxide, methane, hydrogen sulfide. All the good plant nutrients are nitrogen, phosphorus, and potassium. They're coming out of the digester as in the liquid, and that's can be used for crop fertilizer. So nothing's really lost. All right.
CO2 from their food is considered atmospheric because it's sucking back in. So when the feedstock is not an annual plant, then you would consider it maybe not cycling. Like if the timber industry and trees and all that, that would not necessarily be considered atmospheric.
Great question.
Maybe annual crops, at least, I don't know. It's just a new concept to me.
Great. Yeah, I think I would agree.
Well, because fossil fuels would be a different time frame too than what they, so that's where my mind is going, like, where do we stop? So, okay.
Good question.
I just haven't thought of it before. There's a standard.
If I could channel Dr. Richard, who's not here today, I would say, photosynthesis is a very powerful consumer of carbon dioxide. Like we can actually see, or scientists can see, the decline in atmospheric carbon that's seasonal every year because of the photosynthetic drive. So, but that's a big picture question that I can't really answer in terms of the sustainability.
Well, when fossil fuels were being made, the carbon dioxide content in the air was very high.
Good point. Yeah. Again, we're getting a little outside of expertise, so if I can move on. Great. All right. Thanks. I have a few benefits up there back. Yes. So if you're talking about farm biodigesters, we can reduce manure odors. Okay, a lot of farmers, if they're farming near neighbors, they might get complaints about the smell of their farm. And so biodigesters can help reduce the smell of manure because we're processing it in a way to actually digest the stink out of it. So that's valuable. If we are doing better manure management, we can then reduce water pollution. If we are doing better methane management, reducing air pollution, reducing greenhouse gas emissions. If we're digesting food waste, reducing landfill loading. It's a really big priority of the EPA and Pennsylvania DEP is to get food waste out of the landfill. About a third of what goes to landfills right now is digestible material. It doesn't belong there. And once we mix food waste, which is full of nutrients and energy, we mix it up with batteries and diapers and broken toys and stuff. It's kind of lost to humanity, right? We don't want it back for farming. But if we divert it right at the kitchen, send it to the farm and digest it, compost it, what have you, we're doing a great thing, saving those nutrients. We can generate energy, right? Gas or electricity, crop fertilizer, farm revenue, and domestic energy security. That's our fun. All right, and it's fun, right? I love making biogas. We do it with kids. It's not complicated. You don't have to be an engineer to make biogas, right? We have a bunch of these little digesters. So there's the batch digester like we saw outside, and this is a type of a continuous feed digester. We've got a loading on one end and an evacuation pour on the other end, like a drain. If I feed a little bit here, you imagine if there was a water line going through there, right about here. That snorkel will allow, say I put in half a gallon here, it's gonna push out half a gallon of effluent on the other side. And so every day I can feed it at a quart of material, what have you. It's gonna push out a quart of effluent, give it a little stir, and that's a living system it's feeding, it's eating and it's pooping every day. And it's going to be pushing out some gas. All right. Yeah, good question. Residence time. We want a residence time of between, like, standard for mesophilic temperatures, which is cow body temperature, around 100 Fahrenheit, is about 30 days. So we want our stuff to live in there for about 30 days potential time. And so you would divide the volume by 30 and feed it that volume per day. Great question. Okay, here's an example of some of our lab stuff, early designs, testing different substrates. Again, there you see that there's the slurry going in one end, coming out the other. All right. Are you guys okay with these images in the bright light? You want dim light?
the food that you put in, food waste that you're putting in there, you're obviously, you started an instrument before you're like grinding it up.
Yeah.
Okay, so you're really pouring like sort of a slurry of food in there, right? So it's a liquid.
Thanks, Ron. Yeah, it's a slurry. Because we're flowing through, in these cases, like 1-inch pipes, 2-inch pipes, what have you, we want to be pretty thin. Yep. Bigger digesters, maybe, I've heard of people putting whole pumpkins in, but, I would rather chop it up. And the pumps that we use are high solids pumps. We have grinder pumps and chopper mixers and stuff like that to keep everything moving. Yep. On a home digester like this, my friends have in their yard, they have an extra garbage disposal. Yeah, a sink, they put all their melon rinds and stuff through that garbage disposal, catch in a bucket and keep the digester out there. Great question. This one we built, it's roofing membrane, a EPDM roofing membrane. We glued up into a burrito. That's our first bag digester. This one, those of you who have been at the Energy Festival a long time probably met Biogas Bob. Biogas Bob was my mentor in Biogas systems, and he designed this one. This is called Athena. It's Biogas Bob's Athena, and we built that in 2015 at our farm with Bob. Sadly, Bob passed away in 2020, but his legacy lives on at our farm, and we miss him quite a bit. So this is our bigger one that we built there. This one, put it in a greenhouse, keep it warm. So we can, again, we want to keep things around cow body temperature, 100 Fahrenheit approximately. They work a lot better at that temperature. Here we are loading it with a little gravity feed stand there. And the design of that one looks like this. We've got a loading tank, put in like 100 gallons at a time. We fed that 2 to 3 times per week. We've got about 1,000 gallon seeder liquid. And then when we put in 100 gallons over here, it's going to push out 100 gallons of digestate or effluent the other side. And the gas bubbles up to the top. We send that to our storage tank. Go ahead.
Did you build insulation under it?
We did. Yeah, we insulated the ground. We even put heat pipes under it. It didn't work. So mostly it's like a 2.5 season digester. It didn't work because that plumbing is, it could work on your project. Okay. Things like this, greenhouse projects, watch out for rats. Okay, we had one fail for mice or rats getting under it in a warm space, chewing on the rubber, infesting, things like that. So mice and rats like warm places where they can hide.
Is that just one chamber?
Yeah.
So you're continuously removing feedstock as well.
You got it. We're moving effluent.
No, but there's some feedstock in the effluent that hasn't been changed, right?
Yeah.
Because you make.
Yeah, absolutely.
Is there not some way of?
There's no baffle in that. Yeah. Yep. So this is called a plug flow. That's a great question. So in engineering, we would call this a plug flow system. So you think of like a long snake, where some material comes in this end, it's going to chase some other material out the other end. And in an ideal plug flow system, you can kind of imagine that it compartmentalizes like this is here today, tomorrow, next day. But yeah, in fact, it's not ideal. There is some mixing, and some influent might come out the other end. This one's actually 30. The one in the picture is 32 feet long, so it doesn't have a whole lot of mixing in there. Great question. All right. Yeah. When I made the picture, that the circulation pump was working. It for full operating this like full blast, it helps to recirculate some effluent back into the feeding end. Great question.
So when you take out the material, you use that as a nutrient or a fertilizer, or is that used for the cows?
Correct. Yeah. So we want to put that somewhere useful. It's full of nutrients. It's got water in it. We can recycle a little bit of it back into the feed as a microbe store. So this digester, I'd say we run on cow manure and food waste. We ran this one for a year with no cow manure, only food waste. So we would put in food waste and water through this end, run that circ pump, push some effluent back this way to seed it, and then give it a little mix, by pushing on it by hand. And then that thing ran for a year with no cow manure.
So do the farmers do an analysis for nitrogen, phosphorus, potassium to augment their fertilizer to maintain an NPK ratio?
So on a farm scale project,
Yeah.
we are testing the digestate for NPK and we have a nutrient management plan. So like,
Right, they can adjust their external commercial fertilizer that they have to add.
Correct.
So how much less fertilizer do they have to add because they're using their digestate?
great question. So I can answer that better next year.
Okay.
We just built our project. We have a 500,000 gallons of digestate on hand. We're about to start planning that to land now. And I haven't even tested it yet for NPK, but so I'll have more data a year from now. Great question.
Like a pump sprayer or fertigation for drip irrigation? Or
So what we've been doing with it, like my team, we're taking it and we're applying it to the compost. So we're an organic farm. We can't put it right on our crops because it has manure microbes in it.
Okay.
So we put it in our compost it, and then apply the compost after it's gone through a heating cycle.
Could you use a starter, like septic filter, something like that to get the microbes going and, the methanogens and all, and then from that apply it directly to, if you're not using manure?
Great question.
Okay.
Yeah.
You don't have to answer, you don't know.
Yeah. Everybody I know that's doing farm digesters are using some manure feedstock to start. Even like the big commercial, again, Baltimore, there's a giant food waste digester. I think they brought in manure to start. So technically it's going to have some E. coli or, critters that went in to begin with. And the organic, certifiers then consider this to be like raw manure. They treat it the same as raw manure.
Yeah, it's just,
Yeah. Now my dairy farming neighbors who are growing corn and soybeans, they're going to land apply it directly. So they have a tanker, 6,000 gallon tanker, and they're going to drive over the field and just soak it
okay.
and plant their fall, their what have you.
What's the heat balance in the digester?
Heat balance. You mean that
How much heat you have to put in, or does it generate heat and you have to take heat out?
you have to put in. So this diagram is kind of boring, right? That one works in the late spring, summer, and early fall. And then it shuts down in the winter because there's not enough solar income to keep it at an operating temperature. Our farm digester, which I'd like to show you some pictures of here in a second, that one we're inputting heat, and in that case, to start it, we use electricity to heat hot water to it. But it's meant to be running on just the heat of the engine. So we're running an engine off of our biogas, and
It's heat then.
it's a CHP, so combined heat and power, and that the heat from the engine is what heats the digester at that point. But so that our digester right now, it's at 100 Fahrenheit today, and it is outside. It's insulated, but the top is definitely leaking some heat in the environment. So that's why we need to run our biogas through the generator and constantly putting heat in the system. Good question, but yeah, it's not exothermic. If that answers the question. Great. All right. I don't want to run out of time, so can I just flash through some pictures, guys? All right. This is the old way, right? We, inner tubes and bags. We made a bunch of these biogas bags for carting around the farm. You see a floating drum back here. That's a gas collector as well. Like water in the barrel flows, put a brick on it. So that's for your home scale biodigester. All right. We realized a couple years in, like, boy, we collect 1,000 pounds per day of food waste. And that digester you've been seeing in those pictures, it only eats like 50 pounds twice a week. Okay, so we were making all this biogas with a small amount of food waste, and we realized, like, we have all this food waste. Can we turn that into some other kind of energy that we can use? That's how we got the biogas to power, because we can't really bottle up and sell biogas. We can only cook so much. We can beg people to cook more, but at some point you have too much gas. So biogas to power conceptually it looks like this. Sorry, I move this guy. No, okay, can't. There's an engine down here. That's the CHP engine, and it's a round tank, big round tank with a slurry in there. We're mixing it up. We generate biogas. The gas goes right to the engine, makes electricity. We're pushing electricity out to the grid. We're using it on the farm, and then the heat of that engine goes back in here to warm the digester, keep it at operating temperature. And that's a kind of self-sustaining system where the fuel that's coming in is the food waste in the counter. And
That's an engine and a rotating generator.
right, yep, it's a generator.
Or shaft energy for the engine that turns the generator.
Yep, exactly. Yep, yep, and it's a CHP combined heat and power, so it's meant to collect the heat as well as electricity. We're working with the dairy farm had manure management problems. Okay, manure going to the stream is bad, especially in the Chesapeake Bay watershed, so we got a lot of funding to help clean up that manure problem, build our project. We also have a lot of food waste. This is brewery waste from a local brewery, bakery waste, food bank discards, farmers market waste. We're about right now about a ton per day. Also apple waste. This is a lab where we test all that stuff. We can check the energy output of different substrates. And so I talked about floating cylinders earlier. These are the little floating cylinders. We put a meter stick on there. We can measure daily production of gas, compare different things. So my master's research was on brewer spent grain with cow manure as a substrate. And we want to know this brewer's grain, how many, let's see, how many cubic meters of biogas can we generate per kilogram of fresh brewer's grain, right? And I got a number, right? That's from, 2 years of work. That number, and we can punch that into the system and figure out, okay, with all this stuff we're going to bring in, how many pounds or kilograms of stuff are we bringing into the project? This is the amount of biogas we expect to generate per hour. About 25 cubic meters per hour, which is what I need to run the engine that we have for the project. So this is kind of the background calculations that when we're designing our project. Like how much waste do we have? What kind of engine can we power this project? Yeah, that won't be on the quiz. When you build a project of the farm scale, there's a lot more permitting and design and fundraising that goes into it than these owner-built projects like you saw previously. So we started this project. Dr. Epstein was my professor in 2018 and did a design project with other students. That was our feasibility study in 2018. 2020, we started fundraising, permitting, engineering in 2020. 2024, we're almost done. Okay, we've commissioned the project. We're almost done commissioning them. So it's been a really long, hard slog. Engineer, township manager, fire marshal, all those guys are there, right? There's a lot of funding out there. And I don't want to bore you with details, but if you want details on where you get the funding for these projects, contact me offline and we go over that. Our project is costing about $2 million. And we have a lot of money from ag funding as well as US EPA and Sustainable Energy Fund of MedEd, Berks County Community Foundation, and other local foundations, et cetera. So we did quite a funding package to pull it all together. Dickinson College has put in about $700,000 so far, and Larry and James are helping us get some of that back. So thank you. Okay, lots of engineering. What are we doing on time, fellas? 7.
You got 2 minutes.
Okay, all right. Here it looks like construction on the fly. So big tanks for food waste. We built a barn for the cows. Cows are in the barn now. We pushed the cow manure like that with a machine down into a pit. There's my neighbor, her dairy cows. That's the cow manure pit. And we built these big round tanks. Yeah, that's a 600,000 gallon effluent tank. Here's my students Biodigester being built. There's some graffiti. We insulated the tank when it went in the ground. This is 115,000 gallons. There's the heat pipes in the digester to distribute the heat of the engine, circulating hot water there. And then there's the digester full of liquid now. It's got 115,000 gallons of liquid in there. We put that's a gas pipe going around the surface. There's a rubber cover on top of that to catch the gas. It's all bolted down and caulked around the sides. That's the power shed in the back there, where the gas goes right into the power shed to run this engine. This is our 48 kW CHP engine from Czech Republic. And pretty awesome. Made to run on biogas, very sophisticated. Here's what it looks like from the sky. So we got the barn digester manure pit. And then this is our compost area right next door. We're put the digestate over to. And there we are next to the dairy farm with the creek right across the street there. So that's why we were able to get some nice ag funding, was the dairy was leaking manure to the stream. Now we've contained that manure and we can land it flat when we need it. All right. Yeah, we talked about that already. We do a lot of youth education. So we have a lot of little kids and adult kids come see the project. Part of our mission. We got a nice YouTube video series. If you like YouTube videos, check us out. Dickinson College Farm Biogas on YouTube. And that's it. All right. All right. I appreciate all your questions. I hope I answered most of them. And I hope you got excited. If you want to know anything about biogas, want to come see our project, please do. We do take visitors by appointment, and it's a lot to see. If anybody you know that wants to do one of these, have them contact me, please. All right. You're gonna shut up.
Thank you.
Thank you.